अच्छा, so ठीक है. Did anyone else have a question? W20 QP11. ठीक है, that's. अच्छा, एक question था. This one is what? It's coming out to be C or D?
C.
ठीक है, so extended root. I'm just going to explain this. Why did I not take the? I'm taking the Kc expression as products. This is the product side, and this is the reactant side. So the expression is still products over reactant. So that is what Kc is. It doesn't really matter whether because he added this initially, so the container had this, and these were produced, but these were going to be produced in the same ratio. So it's going to be X mole per dmq, and this is also going to be X mole per dmq, but the expression does not change. So which is why the Kc expression is exactly the same, and it's going to be taken as 0.27. So okay, this is coming out to be C, and we'll start with this paper, which is W20 question paper 1. Question paper 1-1. Okay, I'm going to start in the reverse order, which is organic first. So starting with this one. First thing, you've got a polymer, and which reagents react with polymer X. So first one, aqueous sulfuric acid. Will it react or will it not react? What's with sulfuric acid? With this one, will it react or not?
No, it won't.
No reaction.
So just 1 second. There's going to be a reaction. What is this molecule? I know it's a polymer, but what is this? This is an ester link, right? So this one is an ester link, and ester links have serial bond O and O. And remember, esters, they get hydrolyzed. If you have an ester, they have two types of hydrolysis. One is dilute, and the other one is alkaline. In both cases, the ester will break down into carboxylic acid, and this side will turn into an alcohol. So you've got two types of hydrolysis. One is with an acid, the other one is with an alkali. Is that clear? That's an ester. Esters did break down. So which is why 1 and 2 will be correct. Sodium is not going to work. Sodium is not going to work. So sorry. Just 1 second. Where is my? Sodium. Sodium is going to react with alcohols. It reacts with alcohols, and it reacts with carboxylic acids. Carboxylic acids with sodium, they give a positive test. So sodium reacts with alcohols as well as with carboxylic acid. This is not an alcohol. It's not a carboxylic acid. So sodium is not going to react. That's not going to be the correct option. So next one, the 3 reactions of primary alcohols are listed. Which reactions give water as one of the products? First one is, what happens with alcohol reacts with ethanoic acid? Will it produce water? What does it produce? Okay, so an alcohol with a carboxylic acid will produce an ester, and it will also release a water molecule. This is what happens, that when you have a carboxylic acid and you have an alcohol on the other side, the OH and the H are lost in the middle, and the two groups, they join up. A reaction with HBr, will it produce water or not? Okay, it's reacting with so will it produce water or not?
Yes.
Okay, so that one will also produce water. The OH will be lost. So the OH will be lost from the alcohol. You have an OH. The Br is going to replace it, and the H and the I mean, the H would go from this side and they're going to form water. This is dehydration. Al2O3, dehydration is a water is going to be produced by default. Dehydration is that the alcohol gets converted back into an alkene. So that will also produce water. In that case, if you have an alcohol, the OH will be lost and the H is lost from the neighboring carbon atom, and the double bond is formed between the molecules. So now moving to the previous one, question 38. During the bromination of methane, the free radical, so you've got a free radical, and the free radical methyl is generated. A possible termination step for this reaction is the formation of C2H6 by the combination of two free radicals. What could be produced in a termination step during the bromination of propane? So you've got, so let's discuss free radical substitution. So here's my propane molecule. I'm drawing all the hydrogen atoms. What is the first step when you're doing bromination? What is the first step in free radical substitution? What is the name of the step?
Initiation.
Okay, that is initiation. And what happens in initiation? Free radicals are produced. You got bromine radicals, and those bromine radicals will dissociate homolytically, and they would end up producing two bromine atoms with unpaired electrons. And that is where reactive free radicals are produced in the first place. Now, the next part is what happens after that. You got propagation step. Propagation is where the bromine radical has incomplete bonds. So it's going to steal any one of the hydrogens. And that could be any one of them. It could steal a hydrogen from the first carbon atom. That hydrogen is going to go over there and it will form an HBr molecule. What will happen to the rest of the molecule? It's going to become a radical. This carbon atom will have incomplete bonds because the H is lost. So one of the carbon has unpaired electrons. Its bonds are not complete. So that is the second step, propagation step. Now this bromine radical over here, it can steal any one of the hydrogens. It could also steal one of these hydrogens as well. So let's say it does that. In that case, you'll have another radical produced, and that radical would be the middle carbon atom, because all the other bonds are complete. The middle carbon is the one where the H has been stolen by the bromine atom. And these are the only two possible radicals that are alkyl radicals that are possible in this case. So the H could either be removed from the ends. If you remove it from this end or this end, it's the same thing. Or the Br can come and steal one of the hydrogens from the middle part. Is this clear that it's only these two, right? Is this clear?
Yes.
So the next step is, what will happen in the termination step? How can these two radicals combine? So the radical could either be the carbon on the end. So if you have two radicals and both of them, the carbon at the end is the radical. So the bond will be formed between these two carbon atoms right in the middle. So you'll have a straight chain hexane. So you'll have a molecule which will have these are all hydrogen atoms. And the middle ones have joined up. And they've completed the missing bond. Is this clear? The termination step, the result of termination step.
Yes.
So what's the other option? The other option is, yes.
Why can't bromine attack over here or here?
No, it's the same thing. The radical would be this carbon atom, right?
Okay.
So it's going to be the same radical.
So in termination, two bromine radicals can again combine together to form bromine.
Again, that's not, you're not going to write that because it's not going to be, because nothing new is being produced. You're forming bromine back again. It's just the reverse of the first step. So the reverse reaction is not written as a termination step. Is the idea clear?
Right.
Plus, I'm not talking about bromine because he's only talking about the organic compound that are possible. Okay. Achha, so what else can be found? One of this radical can combine with this one. So if they combine together, so you could have a carbon radical at the end, and you could have another propane where the carbon in the middle is the radical, right? Okay, this is this one, the middle one. So the two carbons can join up because their bonds are missing and they can join up in the middle. Or what else can happen? What else can happen is that you can have two propanes and the middle carbon atom is the radical. And the two propanes, they join up. So is this clear that there are three options? That you could either have a carbon radical formed at the end, right at the end, and there could be two propyl radicals and they could join up. Or it could be one of this combining with one of this. This carbon over here connects with this carbon over here. The carbon in the middle joins up with the carbon at the end. Or it could be two of these molecules joining up. The carbon in the middle joins up with the carbon in the middle of the other molecule as well. So is the idea clear? Hanji.
Sir, इसके three different possibilities होंगे ना?
So you have three different possible. I mean, the actual possibilities are a lot because there's a lot of bromine substitution happening as well. So maybe there are, but right now we're not talking about bromine substitution as such. Okay? But in this case, there are going to be three possibilities. Now, which ones are the correct options? So is one correct or not? Is it any one of these? If you look at one, and if I draw one, it's 1, 2, 3 carbon atoms. And on the third one, there's a CH3 branch. That's another carbon atom. And on the right side, there are 2 carbon atoms, right? So is this a possibility? That's not going to be a possibility because whatever happens, there's a propane that combines with another propane, propyl radical. There's a propyl radical that combines with another propyl radical. There over here as well, there are 2 propyl radicals. So whatever my products are, I can split it up into 2 molecules, 2 propyl radicals. I can't do this over here. Like if I break the molecule over here and I assume that the 2 molecules were joining up at this point, then one side has 2 carbon atoms, the other side has 4 carbon atoms. That's not possible in propane. If I assume that they joined up over here, that's the same thing. So you don't get 2 propyl radicals. So the first one is definitely incorrect. Is this clear?
Yes.
So?
हाँ.
सर वैसे normally भी कोई branch structure तो नहीं हो सकता ना उसका?
किसका?
ये जो आप जो मतलब वो radicals हैं, उनके तो हमेशा like linear chains होंगे ना, connect हो रहेंगे end to end.
Why? I just showed you, okay, you can connect the middle part as well. I mean, the H could be lost from the middle part as well. So the middle carbon atom could become a radical as well. Is that clear?
Okay.
So one propyl radical, there's another propyl radical over here. The end is the radical over here. The middle one is the radical, and they could join up in the middle. So this one is going to be a branch structure. Okay. Achha, what about the second one? The second one, what does it look like? It's 1, 2 carbon atoms, and then there's a CH3 branch. So that's 1 carbon atom. Then there's a CH, and after that CH, there are 2 CH3 groups. So this is number 2, and that is correct. Because if I split it into 2, this one looks exactly like the one that I drew at the end. It's a propyl radical. Like if I break it up in the middle, I'll get 2 propyl radicals. The carbon in the middle is the radical, the carbon in the middle is the radical, and they would join up. Okay, so this one is a possibility. This will be formed from free radical substitution of propane. Okay, is this clear?
Yep.
Yes, sir.
So what about the last one? The last one is, I think it's this one. It's like if I draw this, so the last one looks like this. It's 3 carbon atoms in a line, and then there's a carbon atom, and on that carbon atom there are 2 carbon branches. So that means it's 2 propyl radicals that are joining up at this point. This one was a propyl radical. This one was also a propyl radical, and they ended up joining in the middle. So it's the one that I drew over here. So the third one is also going to be correct. That's also possible in free radical substitution. Is this question clear?
Yes.
So next one, so remember in free radical substitution, remember this, that, I mean, you get a lot of questions like these. Remember this, that any of the carbons in the chain, they could become a radical. Because when the bromine radicals, they attack and they steal away the hydrogen atoms, it could be any of the hydrogen atoms. It could be the one over here, or the one over here, or the one in the middle. In this case, there are only two possibilities of the radical. It could either be on the carbon at the end, that's a radical, or the carbon in the middle, that's a radical. And they could connect. The radical carbon is the one which has incomplete bonds. It's the one that wants to make a fourth bond. So those carbons could connect in these three different combinations. Next one. You've got this molecule and seeing that the MR of this is 116. So you got to figure out the number of carbon atoms. That's 1, 2, 3, 4, and 5. So I've got 5 carbon atoms. I've got 3 oxygens, and I have to work for the hydrogens. This one will have 3. This one will have 3. This one will have 1. And there's 1 over here as well. So that's a total of 8 hydrogens. Okay, so this is carbon with 3 H's, carbon with 3 H's, carbon with 1 H. Carbon already making 4 bonds, 1 H here. So all I have to do is I have to figure out whether the MR is 116 or not. It doesn't look like 116. It is?
It is.
So it looks like 116. So it contains 2 groups that show strong absorptions in the. What is this absorption infrared? 1640, 1700 strong absorption.
Double bond O.
Okay, that's a serial bond O absorption, and it has 2 serial bond O's. It's got 1 over here and 1 over here. So it contains 2 groups that show. So definitely you got a carboxylic acid group, you got a ketone group. Its only infrared absorption between 2500 and 3000 is sharp and strong. This is a carboxylic acid. So will it be sharp and strong? Like I'll open the data booklet.
It's gonna be broad.
So wide over.
It's going to be this one. It's going to be strong and very broad. Why? Because when you have an OH that belongs to a carboxylic acid, you got a strong and very broad absorption. So that part is, the third one is wrong. Second be safe that the third one is wrong. So then 36. After a short time, you think X, Y, and Z are each contain water. And a small sample of NaCl is added to test. What happens when NaCl is added to water? Do we have a reaction or what happens?
No reaction.
No reaction, it just dissolves. So the pH is going to be 7, right? So pH in test tube X is 7. What happens when SiCl4 is added to water? Do we have a reaction or not?
Yep.
You got strong hydrolysis, and silicon hydroxide or silicon oxide is produced, plus HCl is given off. So you get an acidic solution, because there's an HCl. There's going to be a solid precipitate that's formed, so the pH would be 2. And with AlCl3, you also have a similar reaction. You have hydrolysis, aluminum hydroxide or oxide is produced, and HCl is given off. So that's going to be pH 2 as well. So
right only.
all 3 look to be correct. So which row correctly shows? Nisara, I didn't get to HCl plus SO2. It's this one. Let me open this. Okay, these are the reactions. Just going through chlorides once more very quickly. That SaCl4 reacts to form SiOH4, SiO2 plus HCl, which is a solid white precipitate, and PCl3, PCl5, they've got strong hydrolysis as well. Okay, I'm going to share this board 1 second. Okay, I've just posted the board link. You have to open it not on your laptop. Okay, it won't work on your phone. Achha, coming back to this, we've got which work correctly shows the relative electrical conductivities of the sets of 3 period 3 elements. So sodium, aluminium. That's the first one. You got sodium, silicon, and chlorine. So does the first one make sense? Yeah, it kind of makes sense because sodium is a metal. It obviously conducts electricity. Silicon is a semiconductor. So it can be used to conduct electricity, N-doping, P-doping. Chlorine is a covalent molecule, doesn't really conduct. So the first one kind of makes sense, and they're talking about electrical conductivity. What about the next one? In period 3, which one is the best electrical conductor?
Aluminum.
So aluminium का higher charge होगा.
Okay. Aluminium has a lot of delocalized electrons. Then magnesium is also a good conductor, and phosphorus will not conduct. What about the last one?
Sir, it is wrong.
Wrong.
Okay, and why is it wrong?
Because silicon is a
क्योंकि
vector
sulfur
conductor.
पहले आ रहा है silicon से.
Okay, silicon is actually a semiconductor. Okay, it conducts moderately. Not a good conductor, but it's not a very bad conductor as well. So silicon, if they're all non-metal, silicon must be at the top. Now, the next one is you've got the process. There's an equilibrium reaction. The process can be carried out at this pressure in 1150 kelvins. And which statement about this reaction is correct? Increasing the temperature will increase the rate of the reaction because more effective collisions will occur. True or false?
Wrong.
True.
False because it's
Sir, it is true. वो equilibrium को
it's
affect
true,
करेगा,
sorry.
rate को affect नहीं
Okay,
करेगा.
remember, always remember that they're going to confuse rate with equilibrium. Okay, this question is specifically for rate of reaction. When you increase temperature, what happens? You get more effective collisions. The collisions are more violent. Not only are they more frequent as well because the particles are traveling faster, but they also happen. Isha. But they also collide more vigorously or with more force because they have more kinetic energy. So that is true. As lowering the temperature will reduce the rate of the reaction because the forward reaction is exothermic.
Wrong.
True.
Lowering the temperature will reduce the rate of reaction.
Right?
I mean,
Yeah.
this is true, right? But this because part is wrong. Because it has nothing to do with whether it's being exothermic or being endothermic. Rate depends on temperature, that if you lower the temperature, the particles will have less kinetic energy. They will travel less quickly and they would collide with each other with less effectiveness. So it's got nothing to do with whether the forward reaction is exo or whether it is completely independent of that. So this because part is wrong. Is that clear?
Yes, sir.
And again, he's not talking about equilibrium. He's talking about the rate of reaction. So rate has nothing to do. It's only that the collisions will happen less frequently. As the next one, increasing the pressure will reduce the rate of reaction. First thing, that is wrong, because when you increase the pressure, you're basically compressing the gas. If you're increasing pressure, so the particles would be closer together and you'll have a faster reaction. So that part is wrong. It's not going to reduce it. So only one is correct. Because this is clear. Increasing the pressure increases the rate of the reaction. As the next one, the units of Kc for an equilibrium reaction are mole minus 1 dm3. What would be the equation for the equilibrium? First one, what would be the unit for Kc in this case? The first equation.
No units.
It's going to be no units. It's going to be C concentration into D concentration divided by A concentration into B concentration. So concentration times concentration divided by concentration times concentration, no units. So the first is wrong. What is the unit for the second one?
Mole minus 1 dm cube, cube, yeah.
Okay, so you're going to get the same one as over here. Because Kc would be R concentration divided by P concentration into Q concentration. So it's mole per dm cube divided by mole per dm cube into mole per dm cube. And this thing becomes x to the power minus 1. So it's concentration to the power minus 1, which is this thing. What about the last one?
Same case.
He gets the same case. It's going to be Kc over Y into Z divided by W times 2x, right? So concentration, or we can write x into x divided by, this actually would become squared actually, divided by x into x squared, and you'll be left with x minus 1 again. So both 2 and 3 are correct. So next one, you've got which statements are correct? The enthalpy of combustion of H2 and the enthalpy of formation of water, are they the same value or not?
Yes.
Yes.
Okay, so this is the same. You burn H2, it reacts with oxygen and it ends up producing H2O. So that is the combustion of H2, but it is also the enthalpy of formation of H2O, that the element compound is formed from its constituent elements. So the first one is wrong, is correct. I say enthalpy of formation of H2 is minus the enthalpy of atomization. I'm going to leave that. We don't have atomization in our course anymore. The enthalpy solution of HCl is
Yes, sir.
yes.
For 33, it's written A. Like all three are correct.
Neat.
Oh,
it is.
sure, yeah, solid.
Carbon is solid.
The C is solid.
ठीक है, it's solid. ठीक है, just remember that. ठीक है, just remember that. I mean, you have to keep your eye open for this. ठीक है? Just make sure you don't write solids in the expression.
Sir, aqueous is allowed though, right?
Hmm?
The aqueous ones, they're allowed, right?
Yeah. ठीक है, and you don't write water, but only when it's aqueous. Like over here, everything is aqueous, right? So if there was water present as well, so you don't write water in the expression as well. But only if it's aqueous.
I bet.
But most of the questions would be on this solid thing. So we leave the other questions. For enthalpy of solution of HCl, that's no longer in your course. You're given this thing, which statements are correct? The nitrogen forms a number of oxides, NO, N2O, NO2. And the enthalpy of formation values are given. So if N2O is oxidized by O2 to NO2, 16 kilojoules of energy is released. So we need to figure this out. We need to write the equation first. So he's saying N2O, first one, N2O is oxidized by oxygen to form NO2. So I guess not really balanced. I'm going to put 4 oxygens. So is the N balanced? It is. So there's 4 oxygens on this side. On the left side, there should be 4. So 3 over here. So there should be 3 by 2. Right? So we're talking about this equation. He's saying this reaction requires 16 kilojoules. So does it? What data do we have about this reaction? The data that's given is, we know the enthalpy of formation of N2O, that's given over here. So that's given. And we know the enthalpy of formation of NO2 as well. So that is also provided. And the enthalpy of formation of O2 is by default 0. You don't need to form this. So what formula hoga isme? What is the formula that you're going to use?
Reactant minus product.
The product minus reactants.
Products minus reactant. Yeah.
Okay, so the enthalpy of reaction for this particular reaction would be enthalpy of formation of products minus the enthalpy of formation of
Sir,
हाँ
sir, combustion के लिए क्या reactant minus product नहीं होता?
combustion के लिए होता है ना. It depends on the data that's given. If you know the enthalpy of formation of the reactants and the product, I mean, the equation itself is irrelevant. Okay, I'm repeating this again and again. The equation could be anything. It could be combustion, it could be neutralization, it could be anything. Okay? The equation doesn't really matter. What matters is what data is given to you. So if you're given the enthalpy of formation of this, and formation of this, so the reaction enthalpy change would be product minus reactants. Clear?
Okay,
Now what is the value? It's going to be
Minus 16.
Minus 16.
the N2O is 1, so that's 82, right? Minus, there are two NO2s. Sorry, it's going to be product minus reactant. Sorry. Product is
66 minus 82.
33 into 2 minus 82. And that comes out to be minus 16, right? So the first one is wrong, right? Because you're getting minus 16.
Sir,
Sorry, that's
Energy.
correct, right? That's correct.
Sir, will we multiply the formation energy of NO2 by 2?
I did that. Okay, it took 33 into 2. Is that clear? As the next one, the decomposition of N2O to form N2 and O2. So N2O forming N2 and O2.
Sir, isn't decomposition always endothermic?
But I'm just checking. Can we do this using? I mean, and can we prove that? I mean, decomposition is endothermic, but the decomposition of carbonates and nitrates, we've studied that, right? So we're not really sure what decomposition is. Decomposition usually is endothermic, but you can calculate this as well. What data is given? Are you given the data enthalpy of formation of N2O? That's given, right? And you know the enthalpy of formation of N2 and O2 as being equal to 0, right? So you can apply your formula over here as well. What is the formula? It's enthalpy of formation of the products. So it's 0. The products are 0 enthalpy of formation minus the reactants. So what is N2O? That's 82, right? So what do you get at the end? You get negative. You're getting negative 82. Are we getting negative 82?
Yes.
Yes.
Okay, so it's enthalpy of formation of the products minus the enthalpy of formation of the. It's the same reaction, right? N2O turns into N2 and O2. So this time it's coming out to be negative, right? It's coming out to be negative, and that would give it. That would make it exothermic. Is this clear?
Yes.
So this one makes it exothermic. Okay, so remember that endothermic thing is it only applies to your group 2 carbonates and nitrates. That is endothermic. That requires. Hanji.
Sir, minus 16 ठीक कैसे है? मतलब मैटर क्यों नहीं कर रहे हैं यहाँ पे minus?
Negative sign?
जी.
He has told us it's getting released.
Oh, okay.
That means it is negative, right?
Mm-hmm.
So next one, last one, the reaction between NO and oxygen is exothermic. So
It's combustion, so it's exothermic.
it should be exothermic, yes. And they haven't told us what is going to be produced. So I'm assuming it is exothermic. We don't know which oxide would be formed. So it looks to be exothermic. I think the only possible oxide is that there's going to be further oxidation. So NO will turn into NO2. Because over here, this is reduction, like NO is +2 over here. So if oxygen gets added, that's further oxidation. Number of oxygen should increase, right? So it should be exothermic, but we can prove it using the data that's given. So again, it's going to be product minus reactants, right? Enthalpy of formation, enthalpy of formation, enthalpy of formation. All of them are given. So NO2 is 33. So that's my product. And and enthalpy of formation of NO is 90. So that's my reactant, minus 90. And that is coming out to be exothermic. Okay, is this clear?
Yes.
Yes.
So this one, again, organic. You've got a skeletal formula. What is the molecular formula of this compound? So all you have to do is you have to count the atoms. That's 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. I'm guessing it's 10 carbons. Hydrogen is difficult. That's 1, 2, 3. 1, 2, 3. That's 6. One over here. That's this one will have 2. This one will have 2. This one will have 3 hydrogens. This one will have 1. Okay, this one will have 2 hydrogens. Okay, just make sure every carbon atom is making 4 bonds.
18.
So, kitna ho gaya? That's 1, 2, 3, and 4,
18.
5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, and you got 18 hydrogens, and you got 1 oxygen. So that's this one. Okay, that's the only available option. Now, compound is chiral, and it reacts with NO2CO3. Who reacts with NO2CO3?
Carboxylic acids.
So it's got to be a chiral carboxylic acid. So this is not a carboxylic acid. Is this a carboxylic acid?
No, it's an ester, I think.
Yeah, that's an ester. This is when you have oxygens between the carbon atom. It's C, and there's a C and there are 2 oxygens in the middle. That is basically this thing. That's an ester link. And the top is CH2Br, and the bottom is C with 3 H's.
Sir, just a side question. The carbon with the double bond O, that's from the carboxylic acid, right?
Yes, like if you want to
Yeah.
hydrolyze it, so that part comes from carboxylic acid. I said, but
Okay.
anyways, this is not a carboxylic acid. That's gone. So you've got these 2 options, A and D. Which one is chiral?
D.
D is chiral because it's this carbon C with H, and there's a Br branch as well, and it's got a carboxylic acid, and you got a CH2, and you got a CH3. So this carbon over here is chiral. As if the next one is what is formed when it reacts with NaBH4? So what is going to happen when it reacts with NaBH4?
Reduces.
Reduction.
So you get reduction. Your ketones and aldehydes will come back to form an alcohol. So nothing else should happen. So it's going to be A, right? The ketone turns into, and that's it. That is the only thing that's going to happen. Okay. Is this clear?
Yes, sir.
As the next one, which pair of test results would prove that a substance X is a ketone? X has no reaction with tolerance reagent. X reacts with alkaline aqueous iodine. Now, does it have no reaction with ketones?
No.
Yes.
I mean, ketones don't have any reaction with tolerance reagent. So that is true. And do ketones react with alkaline aqueous iodine?
Yes, sir.
Yes.
Only one ketone.
Sir, but the aldehyde will react with tolerance reagent, right?
Again, he's saying it's how would you prove that it's a ketone, right? It's the aldehyde will.
Oh.
Okay. So anyways, so the iodoform test cannot prove that it's a ketone because the iodoform test is also true for an aldehyde. It's true for a ketone, a methyl with a serial bond O, but it's also true for an aldehyde as well. Methyl with serial bond O and R being H. Okay, so that's an aldehyde. And the iodoform test is also true for an alcohol as well, a methyl with a carbon which has OH in it. So it's also true for an alcohol as well. So you can't really 100% prove this, that it is a ketone. So you can't do that. As the next one, it can be reduced by aluminium. As it can be reduced by aluminum hydride. Can it be?
Yes.
Yeah.
Sir, oxidized नहीं हो सकता.
It is oxidized. You can't oxidize a ketone, so that's not possible. It reacts with 214 pH and has no reaction. That is the correct test.
Yes, sir. Yes.
That's the correct test. The way you identify aldehydes and ketones is through an orange precipitate that is found when 214 pH reacts with it. And both of them will give a positive test. And if you want to identify one of them out of the two, then ketones don't have further oxidation. I said, Wapis. 26, you've got an alcohol with the molecular formula C5H12O, decolorizes warm acidified potassium manganate 7. So it's an alcohol that is getting oxidized. So it's either a primary alcohol or a secondary alcohol. So it's either one of them. The alcohol also gives a yellow precipitate with alkaline aquacidine. We just did that. Alkaline aquacidine is this one. You need a methyl. It's got this structure in it. So it's that type of an alcohol. It's CH3 with CHOH, and then you have the rest of the molecule, right? So he's saying what could be the identity of the alcohol? So the identity of the alcohol is that it must be a primary or a secondary alcohol.
Secondary.
You could but it can be a primary as well, but it must have this structure as well. Starting with the first one, 2-methyl-butan-2-ol. That's on the second one, there's a methyl and butan-2-ol. Right? So but is 4 carbon atoms, 2-ol means alcohol on the second one, and 2-methyl means a methyl group on the second one. So is this one true or not?
Yes.
No.
I said, why is it not? It's what type of alcohol is this?
Tertiary.
Oh, yeah.
So I said this one is a tertiary alcohol. You can't really oxidize that. As the next one, C-methyl-butan-2 also 4 carbon atoms, OH on the second one, and on the third one there's a methyl. I'm doing B now, so there's a methyl group. Now this one, what type of alcohol is this?
It's secondary.
Okay, so it's a secondary alcohol. Carbon is bonded to 2 chains, so it will decolorize potassium manganate 7. Plus, it will also give a positive test for iodoform. The methyl is next to CHOH. So B is correct. Because methyl with CHOH, that is also true. So yeah, clear?
Yes.
Yes.
So you've got this reaction and it's a nucleophilic substitution. So basically nucleophilic substitution, you got a halogenoalkane, you've got 2 mechanisms, SN1 and SN2. These are your 2 mechanisms. For primary, the OH minus 1 will attack immediately. Cl will leave in one step. So the OH will approach and the Cl gets knocked out. In tertiary, you have Cl leaving first and then the OH comes in to bond with the carbocation. So you got 2 steps. Now this is clearly a 2-step reaction. So we are basically dealing with this one. A tertiary halogenoalkane. SN1 mechanism, right? Is that clear?
Yep.
Yes.
What type of halogenoalkane is this? Primary, secondary, or tertiary?
Tertiary.
Okay, that is a tertiary because the carbon over here is bonded on all 3 sides with a carbon chain. So it is a tertiary alcohol. Tertiary halogenoalkane. So 1 carbon atom in 1 chloro is bonded to 3 other carbon atoms. What is the charge on the carbon atom at point Z? So at point Z, the intermediate, what will happen is in the first step, the Cl will get knocked out. So you'll have a molecule.
So 1 plus charge होगा.
And the Cl will get knocked out. So this carbon over here will get a positive charge. So Cl minus 1 gets knocked out. In the next step, you've got OH minus 1 coming in with its electrons, and that's going to join up. So two-step mechanism, and so your intermediate carbon will have a +1 charge. So we are dealing with this mechanism. The Cl leaves, carbon gets a positive charge, the OH minus 1 comes in. So ये clear है?
Yes, sir.
अच्छा पीछे. A student converts this thing into butanoic acid by a two-stage chemical synthesis. Now this one had 3 carbon atoms. This one has 4 carbon atoms. So what do you think happened somewhere in the middle? How did the
HCN?
carbon chain? Something to do with CN. I don't know whether it's HCN or not, but the carbon chain length increased. So first thing would be, I'm going to substitute the halogenoalkane. I'll have 3 carbon atoms, and I'm going to remove the I and replace it with CN. That's step number 1. And then what I'm going to do is I'm going to turn the CN into carboxylic acid. So it's going to turn into carboxylic acid. So how do you put in a CN? That's ethanolic potassium cyanide or sodium cyanide. Okay, so you had this thing, you were at this point that you had a halogenoalkane, you put in a CN in place of the halogen, and then the Cl got hydrolyzed to a carboxylic acid. So you clear?
Yes, sir.
Sir, it said that we will, which region will react with 1-iodopropane?
We had to convert 1-iodopropane to butanoic acid. So the first step would be you take the iodopropane, replace it with CN. Next step would be you take the CN and turn it into carboxylic acid. Clear?
Yeah. Okay.
So you've got iodoethane reacts with aqueous silver nitrate at 50. The precipitate forms during the reaction, which iodide ions with silver. What color of the precipitate is formed?
Yellow.
Yellow.
Because it's going to be yellow. And is this electrophilic substitution or nucleophilic substitution?
Nucleophilic.
Okay, so halogenoalkanes always have nucleophilic sub SN1, SN2, right? So it's going to be D. Which statement is correct when referring to complete combustion of PVC? What happens?
Sir, A, I guess.
Well, A looks fine. To me, A is perfectly fine. What about the other ones? Carbon dioxide and water are the only products. Well, not. What is the formula of PVC? Like it's a carbon chain, but what's the monomer or repeat unit?
Something with chlorine.
Okay, it's like an ethene monomer which has 1 Cl in it. So the next one is the 2 students each make a statement about 2-methylbutanene. Student 1 states that 2-methylbutanene has geometrical isomers. So first thing, draw this. Butanene, right? So that means double bond on the first one, 2-methyl. That's on the second one, you got a methyl group. So the first, you can add the hydrogens, 3 with this one, 3, and 2 H's with this one. Now, student 2 states that 2-methylbutanene reacts with HBr. Will it react with HBr? Will it have an addition reaction?
Yes.
Okay. And you got 2 options. Either the H gets attached over here or the Br gets attached on the right side. Where does the H like to get attached to?
With more
At the
hydrogen
1
atoms.
position.
The one that already has more hydrogen atoms. So he's saying that an addition reaction takes place, 1-bromo-2-methyl butane is produced. So what is 1-bromo-2-methyl? You got a CH3 over here.
It's not correct.
So bromine gets attached on the double bond and H gets attached. So this is formed. So are both students correct or not?
They're both wrong.
No.
You want both right?
I don't get the statement for the first student, but obviously the second one is going to be wrong.
The first one states that he's saying that there's an alkene and it reacts with HBr. So it obviously reacts with HBr, right? Like you have an alkene and the alkene reacts with electrophilic addition. That's the mechanism.
But
And
the main product he's stating isn't the one which we get.
I said, okay, that part. That way, I mean, you get two products. One of them is major, the other one is minor. So, I said, sorry, he's already stated that that's the main product, right? So it's not the main product, right? The H must have been bonded over here, not the Br, right?
Yeah.
That's what you're saying, right?
Yeah.
So that means the first student is, sorry, student number 2 is incorrect. I mean, that part is done. What about student 1? Does this show geometric isomers?
No.
No.
Okay, so both of them are wrong, right? Clearly, both of them are wrong.
Yes.
Can you just remind me, like, give a quick review on geometric isomers and how?
For geometrical isomers, you need a double bond, and both groups attached to the double bond must be different. Like for geometric isomers, you need a double bond carbon atom, and the bonds would be at a 120-degree angle. Both groups attached to these carbon atoms must be different. Is that clear? So this is your cis version. So over here, it won't form geometric isomers. Why? Because the carbon is bonded to the same type of groups. So in this case, it doesn't really matter whether you switch them or not. As a previous one, structure in CO isomers should be considered answering this question. Compound X, Y, and Z are shown. How many other isomers of C3 are there that are alcohols? So you got, not sure what's going on over here. I think these are mirror images. So how many different, I said that this one is a tough one because you have to draw all of them. I mean, pretty tough. It's how many carbons do we have to begin with? That's 1, 2, 3, right?
3.
So we've got 3 carbon atoms, and we have an alcohol as well. How many H's do we have? That's 1. That's 5, 6, 7. So we've got 6 H's, and we've got an OH as well, and we have a Cl as well, right? That's the formula, right? So ab ye ke what will happen? How many other alcohols? So I can arrange the 3 carbon atoms. That's one way of arranging the 3 carbon atoms. Put the OH and Cl at the end. That's another way of arranging 3 carbon atoms. That's put the OH and Cl. So I'm going to do this one by one. I have 3 carbon atoms, and I need to make an alcohol. So there's got to be an OH. Now the OH could be at the end, or the OH could be on the middle one. Then I mean, those are the 2 possible positions of the OH. Now we can bring in the Cl as well. Like if I bring in the Cl, how many options do I have? I've got an option where the Cl could be on the same carbon atom, or I've got an option where the Cl You got an OH, and I've got an option where the Cl could be on the middle carbon atom. Or you've got an option where the Cl is right at the end. Is this clear?
Yes.
Yes.
So by just changing the position of the Cl, I've got 3 isomers. The other 3 I'm going to make is, so the other 3 are, I'm going to use the branched carboxylic acid and make isomers on that. So I've got,
So how you only have one option.
no, sorry, I'm going to put the OH in the middle one, and I'm going to play around with the Cl. So I've got 2 options. Either Cl is at the end, or the Cl is in the middle, right? Is that clear?
Yep.
So how many isomers do we have at the moment? Now, some of them,
X और Y cis and trans version नहीं है?
you don't have cis and trans because there's no double bond. This is
Oh yeah.
optical isomers.
हम्म.
अच्छा यहाँ पे बताओ, is this chiral, this one?
Yes.
Yes. Yes.
That's chiral. So that's, you're going to count it as 2, right? What about the next one? Is this chiral?
Yes.
So that's going to be counted as 2 as well. What about, I guess this one is also chiral, right?
Yeah.
Yes.
And the last one, is this chiral, the last one?
No.
No.
Okay, that's not chiral. So anyways, you got 1, 2, 3, 4, 5, 6, 7, and 8 in total. Now, if you subtract the 3 that he's already drawn, so 8 minus 3 would give you 5. I mean, the ones that he has drawn, they're part of the isomers that you've drawn. Like, for example, this one over here. Which one is this one? This is the middle carbon atom with an OH and a Cl. So this one is,
One
I
at the
think,
bottom.
I think it's this one. Where this one is the end carbon atom having everything. That's which one is that?
The right one?
I think it's this one, right? This one. Because that's this one. So anyways, we've already drawn these 3. So out of the 8, what I've done is I've subtracted the 3 that were already drawn. So in total, I've got 5. ठीक है, clear?
Yes.
And just make sure that you don't miss out on any isomers. Do it systematically. Like the first thing I did was I fixed the position of the OH. I had 2 groups. Like in this molecule, I had 2 things that I could move around. I had OH groups and I had Cl groups. I couldn't move the carbon chain because with 3 carbons, that's the only single arrangement that's possible with three carbon atoms. So what I did was I first fixed the OH position right at the end. In the other ones, I changed the OH position. I put it in the middle somewhere. And once I did that, I started moving around the Cl. I mean, that's how I was pretty sure that I did not miss anyone. I say, well, sulfur dioxide reacts with calcium hydroxide. What is the main product? What salt is going to be produced?
D. No, sorry, C.
I think it's going to be C.
Hello.
Yes, sir.
Can you hear me now?
Yeah.
Yep.
Okay, that's fine, right? Anyway, so decomposition temperature of the carbonate down the group increases or decreases?
Increases.
Increases.
Okay, so it's harder to decompose, and first ionization energy down the group decreases or increases?
Decreases.
Increases.
So that's T. T get bigger atoms, easier to lose electrons. Ammonia can undergo an acid-base reaction with hydrogen chloride to form. This is the reaction. Ammonia reacts with hydrogen chloride, and it's going to form a salt, which is ammonium chloride. Now, which statement? The ammonium ion is basic. Is it basic?
Acidic.
You remember ammonium ions already have H plus 1 ions. Ammonium ions, they tend to lose H plus 1 ions. So anything that loses H plus 1 ion, that's acidic, not basic. The hydrogen atom from the HCl donates a lone pair of electrons to the nitrogen atom. Is that true? Like you have NH3. Firstly, tell me, why is NH3 basic? Like, why does it accept H?
It accepts
Data
a
covalent
proton.
It can accept a proton, right? Why? Because the lone pair attracts the H plus 1 and they can form a dative bond, right? Now, that's how ammonium ions are produced. So who is accepting the lone pair? That's H plus 1, right?
Yep.
And ammonia is the one that's donating the lone pair. So the hydrogen atom from HCl donates a lone pair. No, it accepts the lone pair, not donates it. Is that clear?
Yep.
What is the HNH bond angle in ammonia is the same as bond angle in, is the bond angle the same in ammonia and ammonium ion?
No.
No.
Okay, because over here you got 4 bonds. When you have 4 bonds, what's the angle?
109.
109.
109.5.
So in the case of ammonia,
107.5.
okay, 107. You have 4 pairs of densities, so the shape is kind of almost the same, except the lone pair repulsion is stronger, so the angle sort of shrinks a little bit. So C is also wrong. You're left with D. That's your answer. The bond angle in ammonium is the same as the HCH bond angle in methane. That is 109.5. So that's true. Okay. So which compound does concentrated sulfuric acid react both as a strong acid and as an oxidizing agent? So when does it do that?
Sodium bromide.
Okay, that's going to be with sodium. Sodium bromide, it will oxidize the bromide to bromine, but it will also displace it. I mean, this is TK, remember group 17. When you do group 17, it's so down the group, it becomes easier to lose electrons. So initially, the sulfuric acid gives an H plus 1 to bromine. It acts as an acid, but then the Br minus 1 starts to lose electrons. The sulfuric acid has to accept electrons, and it will turn into SO2. So both things are going on. हाँ जी.
ये NaBr जो है वो phosphoric acid के साथ act कर सकता है?
नहीं, it won't. ये है ना यहाँ पे this one. That Br minus 1 and I minus 1 will only give displacement reaction with H3PO4. In that case, you will have a displacement reaction. No redox will happen. Like Br minus 1 will not be able to lose electrons because H3PO4 does not like to accept electrons. So which is why no redox happens. But you do get displacement. Is this clear?
Yes, sir.
Okay. 15, you've got a student mixes pairs of chemicals together, excess calcium to water. How many of the mixtures produce a white solid? First one, calcium with water. Will it produce a white solid?
Sir,
Hmm.
आपकी पुरानी स्क्रीन सामने नजर आ रही है अभी तक. I'm not
Saru?
sure if it's only with me. I don't know.
I can
It's
see
the
the question.
same for me.
Can anyone else see the new screen?
Yeah,
I can
it's fine.
see question 14.
Yeah, Rania,
Yeah.
Okay, I'll rejoin.
So this one, you've got calcium with water. What will happen?
It's
What is it?
insoluble, partially soluble.
So calcium hydroxide is formed, right?
Yeah.
And partially insoluble, so there will be a white precipitate, right? So that's one. As a barium chloride with strontium hydroxide, will a precipitate form?
No.
Okay, because if you mix barium chloride is soluble, and strontium hydroxide is aqueous. He's already told us that it's aqueous, so that means it's soluble. So the ions will mix up. The ions would randomly combine, but nothing insoluble forms. Barium hydroxide is also soluble. Strontium chloride is also soluble. So no insoluble thing forming. What about calcium carbonate with excess hydrochloric acid? What is going to be formed?
Calcium chloride,
Chloride.
carbon dioxide, and water.
Okay, which is also soluble. And the last one is barium nitrate with magnesium sulfate. Will a precipitate form?
Yes, because barium sulfate is insoluble.
Okay, so you got two of them, right? It's going to be C. You're going to see white solids in two of the mixtures. Which element is the strongest oxidizing agent? So what does an oxidizing agent like to do? Lose electrons, gain electrons?
Gains electron.
Gain electron.
So
Gains electron.
it gets reduced itself, right? So it gains electrons. So is it a metal or a non-metal?
Non-metal.
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 So you got non-metals that because they gain electrons. So B and D are automatically eliminated because they are metals. You can go and have a look. 3s2 is probably, which I think it's a group. It's magnesium, I guess.
B is magnesium
And this one is probably calcium, right? So these are all automatically eliminated. You're left with group 7 elements. This is fluorine and this is chlorine. So who really likes to gain electrons? Fluorine or chlorine?
A.
Chlorine.
Okay, because that's more electronegative, smaller atom. The nucleus is less shielded, so it has a much stronger attraction for electrons. As the next one, you've got the question is about two elements, group 2, Q and R. The three statements shown are correct for metal Q. The one remaining statement is correct for metal R. Which statement applies to R? So 3 are for Q, 1 is for R. And they didn't tell us what, they didn't even tell what the position of Q and R is. So a saturated solution of the hydroxide of this metal has the higher pH value. So is it a bottom one, or like you got Mg and you got C and you got SR and Ba, right? So whose hydroxide has a higher pH value?
Borons.
The barium.
Barium.
Yeah, that has it's more soluble, right? So that means one of the elements is the one at the bottom. I'm not. Let's think of it as barium, and the other one is at the top. Let's think of it as magnesium, right? So let's say this is barium. What about the other one? The metal has a carbonate that is used in agriculture to produce the acidity. I mean,
Calcium.
that one is calcium. The metal has the greater atomic radius.
Barium.
Barium.
So that's barium. And so instead of magnesium, I'm going to take it as calcium. The metal reacts more quickly with cold water.
Magnesium.
Barium.
Magnesium.
The bottom one. The bottom one is the more reactive one.
Oh, अच्छा.
ठीक है, reactivity in group 2, because down the group it's easier to lose electrons. Metals always like to lose electrons when they react. So it's going to be barium. So I just took barium as an example. But what we found out was that 3 of the statements work for barium, while only one of them is working for calcium, right? So that means R is calcium, right? Is that clear?
Yes, sir.
सर
हाँ.
सर यहाँ पे आप और भी मेटल्स ले सकते हैं, लेकिन आपने बेरियम को चूज किया सिर्फ.
Yeah, I could have taken any metal, but in that case, I mean, let's say, I mean, calcium is fine. We know calcium, right? We know that option B is calcium, right? Let's assume I take some other metal. Let's say I take magnesium as the other metal. So, and let's say the competition is between magnesium and calcium. A saturated solution of the hydroxide of this metal has the higher pH value. So who's going to have a higher pH value? That's going to be calcium, right?
Yes, sir.
Okay, so the metal has the greater atomic radius, so that's going to be
Calcium.
the metal reacts more quickly with cold water. Which one is it going to be?
Calcium.
Calcium.
So now in that case, if I had taken magnesium as the other metal, then all 4 statements would be true for calcium, but he had stated that 3 would work for one of the metal and 1 would work for the other metal. Is that clear?
Okay, sir. Thank you. Understood now.
So that means selecting magnesium would have been wrong, because I need a distribution in answers 3:1. Okay, 3 of the statements should work for one of them, and the other one would work for R. Even strontium would have been correct. Like if I had taken the other metal as strontium, then it would work. I mean, the first statement, higher pH value, that would be for strontium. The metal has the greater atomic radius, that would be strontium as well. The metal that reacts more quickly with cold water, that would also be strontium. So the odd one out would still be B. Okay, is this clear?
Yes, sir.
So I think the way you had to answer was that your distribution of answers, no matter what metals you select, the distribution of your answers should be 3:1. 3 statements work for one metal and 1 statement works for the other one. Is that clear?
Yep.
Yes, sir.
So this one quickly, X and Y are 2 elements in period C of the periodic table. They combine to form Z. Okay, X and Y, they react.
Sulfur dioxide.
So they react to form Z. It can't be
The answer is D.
D.
B, because aluminium is only amphoteric.
The first thing, X forms a soluble acidic oxide. So X is probably a non-metal, an oxide that is acidic, right? So who forms? So this one could be in period C, right? It could be sulfur oxides, phosphorus oxides. Who else is acidic? Silicon oxide is insoluble. I mean, those are the only 2 options, right? Is that clear?
Sulfur will have
Yes, sir.
oxidation number of.
So oxidation number of 4, so P goes because sulfur is +4, right? Y forms an amphoteric oxide. So T, that makes sense. B is correct. There's only one amphoteric oxide, that's aluminium. But this one is wrong because +4, that's sulfur. See, so we're done with this. So you've got an autocatalytic reaction, is a reaction in which one of the products catalyzes the reaction.
See.
Okay, which curve would be obtained if the rate of an autocatalytic is plotted? So C is correct. What will happen is the product is the catalyst. So right at the beginning of the reaction, you don't have products, right? When the reaction starts. So the rate of the reaction would be very slow in the beginning. Is that clear? Because the product is going to catalyze the reaction. So initially you don't have the product, but slowly what will happen is a slow reaction will start and then products will form. So once products are formed, the reaction speeds up. ठीक है, ये भी clear? Is this clear? So slow in the beginning.
Can you explain this once again?
The first thing, remember this, he's already stated that you had an autocatalytic reaction and the product is the catalyst. So if you have a beaker and there's X and Y reacting. So beginning, so 1 second, mic we off kar that. Right in the beginning, there is no product, right? So if there's no product, it will not catalyze the reaction. You clear?
Yes.
So that means there is no catalyst. That means the reaction will not speed up. So initially the rate of the reaction, the height is the rate of the reaction. So initially the speed is very low. Is that clear?
Yes.
Again, after some time, X and Y will react and the product will start forming. Once the product forms, the reaction speeds up. Why? Because the product is the catalyst. Okay. So the curve will go up because the reaction will speed up. Because the products will speed up the reaction. And the rate of the reaction will be higher. Why does it come down again at the end?
So because the product is self-consumed.
The product consumed क्यों हो रहा है? No one is consuming the product.
Because eventually the reactants will finish.
Eventually at one point, at one point, the product will be present, but there will be no reactants. If there is no reactant, the reaction stops. If the reaction stops, the rate of the reaction drops to 0 back again. So which is why it's going to be C. Is this clear?
Yes.
Yep.
Next is you've got what is this? The reaction goes to completion, the first one. The reaction reaches equilibrium with constant C. Analysis of 2 mole per dm cube solution of H2SO4 found the HSO4 ion concentration to be 1.988 mole per dm cube. What is Kc for this? How do I know what is Kc? So how do you measure Kc? There's analysis of a 2 mole per dm cube H2SO4. So this over here is 2 mole per dm cube. How much HSO4 ions are produced? So the amount of HSO4 ions produced is
1.988.
1.988. So that's the amount of concentration of 1.988. My only question is, it's sulfuric acid, Kc, and there is a 2 mole per dm cube solution of H2SO4. Now I don't know if this is the initial concentration or the final concentration. Found the HSO4 ion concentration to be 1.988. Sorry, I got it. The first one is going to completion. So that means 2 mole per dm cube completely reacts to produce how much HSO4 ions? It's going to produce 2 mole per dm cube, right? Is the first step clear?
Yes.
And then the
Which,
equilibrium
if 2 moles make 2 moles of H2SO4 minus, then there's no H plus made.
No, there's going to be 2 mole per dm cube of H plus 1 ions as well.
Okay.
Right?
Yeah, cool.
Because one of this is produced, one of this is produced. So now let's do the equilibrium thing now. So I know at the start, before the second reaction happens. So you have this reaction, the second one. Now, before the second reaction happens, I've got the initial concentration of HSO4 ions is 2 mole per dm cube, right? And at the moment, there is no SO4 minus 2 ions produced, there's no H plus 1 produced. And he has said that the concentration at equilibrium is 1.988 mole per dm cube. So how much HSO4 ions have been consumed? What is 2 minus 1.988?
0.012.
0.012.
So that means 0.012 have reacted, right? And it's 1:1. So that means 0.012 of this is produced. And 0.012 of this is produced. So your final equilibrium moles would be 0.012 of this and 0.012 of this. So if you write the Kc expression now, it's going to be product concentration divided by the reactant concentration. It's going to be 0.012 times 0.012 divided by 1.988.
E?
So divided by
1.988.
D, sir. 7.22 times 10 to the minus 4, minus 5.
So I'm just going to repeat. Initially, you had 2 mole per dm cube of this, but the first reaction goes to completion. So that means 2 mole per dm cube of this completely reacts to produce 2 mole per dm cube of HSO4 ions. So right at the start, at the beginning of the reaction, you have 2 mole per dm cube of HSO4 ions. Then those HSO4 ions will also decompose according to the second equation, and they'll produce a few of SO4 minus 2 ions and a few of H plus 1 ions. So what I assumed was that our starting concentration is 2 mole per dm cube. And at equilibrium, they've already told us that it decreases to 1.988. So that means 0.012 has reacted. And on the other side, it's going to produce 0.012 and 0.012 of this. So my equilibrium concentration comes out to be this and this for the products and 1.988 for this one.
Sir, but in mark scheme, they have written C.
No,
one
I'll tell you what's
1.988 की जगह 0.012 से डिवाइड नहीं होगा.
क्यों 0.012? You had, listen carefully.
Okay.
You had 2 mole per dm cube, and he's already told us that equilibrium cube the concentration is 1.988 mole per dm cube. So you had 2.2 mole per dm cube initially, and at equilibrium you have 1.988. So this is your equilibrium moles. So that means 0.012 are missing. Those 0.012 have gone and produced these two.
Oh, okay,
And-
got it.
Acha, but now the answer is coming out to be C, not D. So where's the mistake?
सर शायद पहले इक्वेशन में H plus को कंसीडर करना हो.
Okay. In the first reaction, the solution already has H plus 1 produced. And how much would be produced? 2 mole per dm cube, right? So the mistake we made over here was that I assumed that these were my initial moles, right? So I assumed that HSO4 minus 1 is 2 mole per dm cube, but there's already H plus 1 present even before the second reaction happens. So this H plus 1 right at the beginning is 2 mole per dm cube. Okay, because there's a lot of 2 mole per dm cube of H plus 1 ions that have already been produced in the first reaction. Is that clear?
Sir,
So
Yeah.
what would be my equilibrium moles now? It's going to be 2.012, right?
Yep.
So try solving this using, it's going to be
You get
0.012.
C.
Now you're getting C.
Yep.
So that's the mistake. That there was, even before the second reaction happened, there was already 2 mole per dm cube of H plus 1 already present in the mixture. So the second reaction after further dissociation produced even more H plus 1 ions. So the net quantity of H plus 1 came out to be 2.012. ठीक है, clear?
Yes.
Yep.
I'd say, what is reduced in this reaction quickly? Who's getting reduced? I guess
Can
Seal
someone help me with the
So screen is a bit
conservators?
so I guess Cl is getting reduced. Cl was 0 and Cl is -1. Yes.
So what about carbon?
So screen is
No, no, carbon.
Nee, is the screen not working?
No, it's working, sir.
Acha, nee, what's the question? Somebody was asking a question.
Yeah, sir. Why not carbon?
Nee, carbon is 0 over here.
Yeah.
Carbon is +2 over here and +4
Ah,
over here. So
my bad, my bad.
it's getting oxidized, right? So
Yeah.
answer is chlorine for this one. In which reaction does the greatest change in oxidation number of sulfur occur? So +6. This is 0, this is +4, right? So this one is +4 and +6. So that's gone. This is +6. Can anyone tell me what's H2S2O7? That's what is sulfur?
12.
Well, it's +1 into 2. I mean, it can't be 12. Sulfur, the 2 of the -2 times 7. That's so
That's a
it's
6
2x. That's a
That's 6, sir.
-14.
I think 6.
Okay. So it's coming out to be 6. So this one is really not oxidation. And +6 to, again, this is not, I mean, the first one, that's A, right? Greatest change, that's coming out to be A. C and D are not redox because no oxidation change happens. Okay, so we've got this reaction, the standard enthalpy change of BrF3 liquid. Formation. Which one is formation out of which arrow is formation of BrF3?
The right ones?
It's this one, right?
Bottom one.
Formation of BrF3 liquid from its elements, right? So this is what is the value? That's -301. There's one thing wrong over here. What's that?
It's 2 times.
It should be multiplied by 2 because you're making 2 BrF3s, not 1 BrF3. What is the enthalpy change of BrF3 liquid to BrF3 gas? So your starting point is this one, BrF3 liquid, and they're asking you to figure out enthalpy change, this one. So what you're going to do is you're going to create this other path. Nee, sorry, they've already given that. BrF3 liquid to BrF3 gas, that's +44. This one is already given. What is the average bond energy of the BrF bond in BrF3? So how many bonds are being broken over here in this path over here?
6.
So you're breaking 6 BrF bonds. Is it going to be endothermic or exothermic? Plus sign or minus sign? You're breaking bonds, right? So it's going to be plus, right?
Right.
So we have to calculate this. So what we're going to do is we're going to travel in this direction first, then from this to this point, from this point all the way till this point, and that's about it. Your starting point is this, and your end over you should end over here. One path is equal to the other path, right? Or you could actually make any of the cycles. It doesn't really matter. You can. That's one path. That's your other path, right? So you can just equate the two paths. So it's -301 times 2. That's path number 1. What's the other path? That's 698. Then it's in the opposite direction. That's -6 times BrF bond. And then it's -44, right? And can you solve? What do you get?
So would you make -44 times 2?
Yes, that should have been 2 as well. because they're two BRFs. So that's one path equal to the other path. That's your
Sir,
test.
the two BRFs are making two BRF3. Matlab, it's going from 2 BRF3 liquid to 2 BRF3 gas. So we're still going to consider this.
Yes, okay. Why are we multiplying it by 2? Then they've given the enthalpy change for one BRF3 liquid turning into one BRF3 gas. So since we are going in this direction, and the two BRF3s forming, so you'll multiply it by 2. But since our arrow direction is the opposite, so we're going in the opposite direction. So these arrows and the sign will change. So BR, I think we're getting B for this one. Is this clear? And the last one is which pair of standard enthalpy changes are numerically equal? You haven't done atomization, so leave that. Combustion of this and combustion of graphite plus 2 combustion of hydrogen. Is this equal? Combustion of ethanol and combustion of graphite doesn't look to be equal, to completely different reactions. Combustion of graphite and formation of CO2, is that equal?
Yes.
Yes.
That is equal. Combustion of graphite is C plus O2 forming CO2. And formation of CO2 is forming CO2 from its elements. So they're the same reaction. Copper has a high melting point. What is the reason for that?
So, D होगा.
B.
Yeah, B.
Copper ions and delocalized electrons. It's a metal ion and a sea of free moving electrons. And the electrons and the positive ions, they attract each other. In which of the following, when in liquid form, are there only intermolecular forces based on Templey dipole? Templey dipole, that's van der Waals forces, right? So who's got van der Waals forces only?
A.
Bromine.
Yeah, that's non-polar, so that's bromine. What about the other ones? What intermolecular force does ethanol have? The strongest one.
Hydrogen.
Hydrogen bonding.
You got HCl. What does HCl have?
Permanent dipole.
Yeah, that's permanent dipole. Water also has hydrogen bonding, right? So this one, there's a particle X in the process, a proton is emitted. What is particle X? A single P nucleus can be produced when a single S joins with particle X. In the process, a proton gets emitted. So S32, right, joins with X, and P32 nucleus can be produced. So P32 nucleus is produced and a proton is emitted. So the question is, what is X?
And
So you just,
Neutron.
I mean, you just have to balance the left side and the right side, right? So how many protons you got? You got 16 protons, right? And you got 16 neutrons, right? On the left side, you've got 15 protons, and you got how many? You got how many neutrons you got? You got 17, right? And there's one more proton. So the protons are definitely balanced, right? You got 16 protons on this side, you got 15 plus 1 proton on this side as well. So that's balanced. So you got 16 neutrons, you got 17 neutrons. So this one must be a neutron, right? Is that clear?
Yep.
yeah.
Yes.
So that's going to be C. Acha, what is the maximum mass of strontium metal that can be produced from the reduction of 100 grams of this? So it's simple moles. Just find the moles, and you can figure out the moles of strontium using that. And can you quickly do this? Last we'll try doing this one. How many moles of strontium oxide do you have? 100 grams of this. And not really sure what strontium is. Strontium is, doesn't even know what the
87.62.
30 gets 87.62. So it's going to be 100 divided by 87.62. So the mole, so the moles of strontium would be moles of this into 3 divided by 6, right? So it's 6:3, right? Or half. Strontium metal would have half the moles. And you have to find the mass of this thing. So how do you find mass? You multiply it by the AR of strontium, which is 87.6.
But so wouldn't you add 16 because it's strontium oxide?
Okay, that's the mistake. You can now solve this.
B.
42.3.
So you're getting B. Which statement is correct? Cl has a relative isotopic mass of 35.5. Is that true?
Yes.
So remember, isotopic mass is the mass of an isotope. And the mass of the isotope is always close to a whole number. It can't be 0.5. I mean, like if I look at oxygen isotopes, they're usually very close to a whole number. Let me call it the Wikipedia page. So for example, I don't know if they've given you, yep, this one. They've given you the isotopic mass. For example, there's oxygen 11. That's the mass is 11.051. You got oxygen 12, which is 12.0 something. This is the most common one, oxygen 16. That's 15, almost close to 16. So the point is, isotopic masses are always usually very close to the actual nuclear number. Okay, clear?
Yes, sir.
And mass, remember, is always in decibels because it depends on the accuracy of the device. So the point is, you can't have 35.5. You can get 35.5 if you take the average of the isotopes. So that is known as the atomic mass. But the isotopic mass is usually very close to a whole number value. Cl2 has a relative molecular mass of 70. Is that true?
No, it's 71.
It's 71 because according to the periodic table, the AR of Cl, or the relative atomic mass, or the average value, is 35.5. And if there are two of them, then Cl2 becomes, the average value comes out to be 71. ICl has a relative molecular mass of 162.4. I mean, the last one is correct. You get D is correct. Does anyone have a question other than this paper or even this paper?
Sir, C, not D.
Need D correct?
No, sir, mark scheme says C.
Wait a second. It's
C is
ICL.
correct.
Huh?
C is correct. I calculated.
C is correct. This is what's wrong
Yes.
with. So what's wrong with D? I mean, is D wrong or not?
That's
What is
also
it?
correct.
That's a NS 23 and
It's-
CLS 35.5.
Because
So
it
D-
is formula mass, not
Exactly.
molecular.
Huh.
22.99 in periodic table. So
Consa.
the sodium.
You're going to use your periodic table, not any periodic table. Your periodic table has 23. If you open your periodic table,
Sir, then D is also correct.
then obviously D is also correct. But why is D wrong? Whoa, somebody just told us that. I mean,
Like
this is your
formula mass or something, right?
because 1 second, where's the paper? I just remember this, that molecular mass is for covalent molecules. Covalent molecules are basically simple covalent structures. NaCl is not a molecule. NaCl is a giant lattice in which you have positive ion. It's a crystalline structure where you have lots of Na ions and you've got lots of Cl ions, and they all get attracted to each other to form a crystal, right? Is that clear?
Yep.
Yes.
सर
हाँ.
आपने क्या एक्सप्लेन किया NaCl के लिए?
Ionic lattices, now you use the word, you use the term formula mass.
So
Okay,
could
all-
you,
See, the point is, if I have a Cl2 molecule, a Cl2 molecule only has 2 Cl atoms. So it's kind of easy to know that a Cl2 is always Cl2. It's not Cl3, it's not Cl4. So you use the term molecular mass for that. But when you have an ionic lattice, like a crystalline lattice, you look for the smallest unit, because it's a giant crystal. It's got lots of sodium ions and it's got lots of Cl ions. So the smallest formula unit is this thing that's repeating over and over again. So the term that's used is, you don't use the term molecule for that. You use the term formula mass. Is that clear for ionic compounds?
Yes.
Molecular. So remember, for ionic compounds, the term, I mean, we keep using the term MR very frequently. Even Cambridge uses the term MR very frequently. But the proper terminology is that you use the term formula mass for ionic or crystalline lattices. Okay? So is there any other question?
sir, I have a question from another paper, or should I ask it tomorrow?
So you can ask me tomorrow then. Okay,
Okay, cool. All right, sir. Assalamualaikum. Have a nice day.
okay, take care.
Allah Hafiz.
Allah Hafiz.
Allah Hafiz.